Hello, this is video number 4. We'll see if it's in 2 parts or not. We're going to do compound interest. This is for quiz number 4. So last time we did simple interest. Today we're going to do compound interest. So the compound interest formula, we need to add a couple of ideas. We talked about A, which is the future value or accumulation value. We also need to add the letter N, which is the number of compoundings per year. It's on your formula sheet number 2 at the top. It has all of the various letters and abbreviations we use for interest. So it says N is the number of compounding periods or payments per year. And the compound interest formula looks like this. So I wrote it as you would put it into a calculator, horizontal. You need this many parentheses. If you don't put parentheses around the NT, which is the number of compoundings total, because if it's N per year and there's T years, remember T is in years, that's the total number of compoundings. If you don't put parentheses around it, the order of operations won't work. So you got to be careful when you're dealing with a calculator. It only does what you tell it, not what you want. So be careful. So, number 1, we have $1,000 for 6 years at 1.4%. That's R. Compounded semi-annually. So N equals 2. Because there's 2 half years in a year, so there's 2 compounding, so N equals 2. So when I put it into the formula, it looks like this. The future value, the accumulated value, will be 1,000, 1 plus 0.014 divided by 2, and caret, N is 2, and T was 6. So you see the exponent's 12. Now, if you want to just write in caret 12, you can do that and avoid the parentheses, but to fit this into the formula, this is how we would do it. So when I do this calculation, and once again, I'm going to add the dollar sign at the end. Don't forget the dollar sign. So this is A. This is the future value. So the question is, what's the interest? Well, the interest is the future value minus the present value. I equals A minus P. So you can see that I is equal to $87.31. I would just subtract 1,000, the principal, from A, and that would give me the interest, if you needed to answer either or both questions. So this is A, and there's I. I think on the quiz, you'll have to answer both questions. Okay? So let's do another one. This one's $2,000 for 4 years. When I write T equals 4, we know it's years. Here I wrote years, but just to reinforce it. 3% quarterly. So there's 4 quarters. Every 3 months is a quarter, so 4 quarters per year. So we're going to have 16 compoundings, because NT is 16. So if you want to do that, you could say N times T equals 16. 4 times 4. So when you do your formula, A equals 2,000, 1 plus 0.03 slash 4 caret 16. So you can avoid the use of the parentheses because you already know what NT is. Just saves a little bit of effort, as long as it's not difficult. When we get into mortgages later, you'll see that you'll have 12 n equals 12 in 30 years, you get some huge numbers. So sometimes you want to just put it in as part of the formula. But that's your choice. So when I do this calculation, I get $2,253.98. Remember, it's money, so we're always rounding to the nearest penny. So what's the interest? That's pretty easy. Just subtract the principal, which is $2,000. And that leaves you with $253.98. So there's your interest, and there's your future value, your accumulation. Okay, one more. Let's do compounded monthly. So this is $7,000 for 3 years at 5.5%, compounded monthly. So now n is 12, because there's 12 months per year. So we do it once a month, so that's 12 compoundings per year. So how much money will we accumulate from the 7,000? So 7,000 is the principal, or the present value. 1 plus 0.055. Remember how to change a percent to a decimal, move it 2 places to the left, slash 12, because now n is 12, and caret, so n is 12 and t is 3. So there's 36 compounding. So you could write 36, or you could do it this way in your calculator. It's your choice. And so when I do this calculation, I get $8,252.64. And when I subtract 7,000, the principal, so this is A, I is equal to this amount minus the starting value, the present value, 7,000. So that'll be $1,252.64. Right? If you just subtract 7,000, you get this. So those are the two questions you'll have to answer for this type of problems. All right, so what we're going to do now is change it up. Suppose that I want to set a future value based on time and rate, and I want to, and the number of compoundings, and I want to know, what do I have to have today to reach that accumulation? So we take the same formula and we just slightly tweak it. Let me show you. So what I do is I just solve that equation that's up there, up in the top left. I solve it for P, because right now it's solved for A. So all I got to do is divide by this whole thing. So I'll put it in another color. If I divide both sides by this amount, so ditto on the left, I end up, and I'll put it in calculator form, I have present value would be the future value divided by, now I got to make sure I use double parentheses, because this whole thing goes in the denominator, so I got to have parentheses around it to keep the order of operations correct. So it'll be double parentheses, 1 plus r slash n, caret n times t. See, I have to have the extra set of parentheses. If you want to make those into brackets so you can see that they're the overarching big parentheses, because you got to be careful. If you don't put those extra parentheses, the order of operations won't work correctly. Chances are you'll run into a problem. So it's best to be safe. So here's an example. Suppose we want to accumulate 75,000. $75 big, $75 large, $75 grand. Remember from the movies? After 5 years, And we're going to get a 4% interest rate compounded every 6 months. So every 6 months, I want to know what n is. So if every 6 months there's 2 6-month periods per year, so twice, compounded twice per year. So I put these numbers in this formula on the right. So the principal will be 75,000 divided by double parentheses 1 plus 0.04 divided by 12 r over n caret. Now here you don't have to use the parentheses. You can just write nt. Nt is 10. So let's just do that. But we still need the other parentheses. So I just eliminated 5 times 2 and wrote 10 instead of 5 times 2. And so we get 61,526 and 12 cents. So that's my present value. If I take that present value for 5 years at this percentage rate compounded twice per year, that money's going to turn into a $75,000 accumulation. You can figure out the interest. Just subtract the principal from here. So let's do it. So the interest is A minus P. So that'll be 75,000 minus 61526.2. So I know it'll be 88 cents. And then 6 from 9 will be 3. 2 from 9 will be 7. And 5 from 9 will be 4. And 1 from 4 will be 3. And so looks like I'll have an interest of $13,473.88. So I did mental arithmetic instead of a calculator. Let's see if I'm right. Boom, 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 boom. Yes, got it. So that's the total interest, which is about almost 20%, a little bit more than 20%. So that if it was 4% per year, then you would have 20. But you see, it's more than 20 because 5 years times 4 is 20, but you're compounding twice per year, so you get a little bit extra than the 20%. Okay? Okay, let's say you want to accumulate $15,000 after 30 years. Let's say you want to be able to buy a motorcycle when you retire, and you know you need $15,000. So how much do I put aside now and just let it grow, and I don't have to worry about any mistakes or whatever? As long as I can leave it there, how much do I need to make it grow? So 15,000, 30 years, 3%. Nice conservative. These are conservative. These are about current rates. You can get those if you put enough money aside. You can get those rates right now. And compounded monthly. So n is 12. So monthly means 12 times a year. Okay. So my present value, which to get this amount in 30 years, it'll be 15,000 / double parentheses 1 plus r, which is 0.03 / 12. That 1 plus r over n, you're going to see this part of the formula. It's going to come up again in some future work we do. It's a stable part of all our calculations. And so caret and nt. So this time we'll just write it out. N times t. See, it turns out to be 360. And don't forget the second parentheses on the outside. So when I would do this calculation, I get $6,105.40. So if I have this much in savings right now, if I stash it away into this account that pays me 3% compounded monthly, and I leave it there for 30 years, I'm more than, that's 150%, right? 100% would be another 6,000, and half of that's another 3,000 approximately. So 2.5 times. That's a 250% gain. over initial investment. So 150% interest. All right. So those are the two formulas for compound interest. So let's do a thought out problem here for a municipal application. So this city has a vote. The city council wants to collect $2.5 million to build a new water tower. And they want to build it 10 years from now. They're thinking ahead. So they don't want to get the money in 10 years. They want to do it now because they figure if they do it now, they can have a smaller principal. It'll grow with interest. So that's their future value, $2.5 million. That's what they need for the new water tower. And they need it in 10 years. So T equals 10. There are 12,450 city residents. They're the ones that are going to pay this money. They're going to pay it each appropriate part of that. So the CD, they're going to put it in, pay 7.5%. That's a nice percentage. I don't care what year it is. That's a great percentage. And they're going to compound it weekly. So that means 52 times a year. And it's 52. See, right now, if I divided the $2.5 million by 12,450 residents, that's approximately $2,000 a piece. I believe that's right. I'm sorry, $200 a piece. Let me double check that. So if I take $2.5 million, I divide it by 12,450 residents. Yeah, $2,008. It's $2,000 a piece. So there's 12,450. We better use a different N. Let's call it capital N. That's the population, so we'll call it capital N. That's the number of people that are going to fund this. So what's the present value to gain the $2.5 million? That's the first step. Because if they needed the money today, it would be $2,000 per person. If they wanted it today, that's a lot of money to shell out for them. But if they plan ahead, it reduces the cost. So the present value for this would be $2,500,000 divided by double parentheses 1 plus R divided by N, R over N, caret N is 52 and T is 10. So 520 compoundings. They're going to compound it 520 times. They get a little bit of extra interest every time they do that. So when we work this out, we get $1,181,554.66. So that's less than half of this. If I could get this amount of money right now, I would get more than double that in 10 years at that interest rate, fine interest rate. So how much does each person pay if they were to do that? So for $2.5 million, we said that I'll call it E. Everybody's was $2,008. For the 1 million, blah blah blah, whatever that is, everybody's share would be. So if I put that number in, see that was 3 cents. If I put that number in, 1,181,554.66 divided by 12450, it's down to Oop, I missed some numbers. Let me start over. 118,155.4.66 divided by 12450. Okay, it's down to $94.90, believe it or not. Yeah, it's a little bit less. Well, I'm going to double check that other answer just to make sure I got it right. Yeah, this is 200. There we go. So right now, that's a little more believable, $200. And if you did it today, it would be $94.90 per person. Okay, but that's not the final question. The final question is, so this is the amount for P. If the council receives a federal grant of $400,000, how much will the surcharge be for each resident, taking the grant into account? So each resident would pay 118,155.4.66 minus the 400,000 divided by 12450. And you can see that if I work this out, I get $62.78. Now that's doable. With the help from the federal government, each resident pays about 63 bucks. They put it into this CD, and in 10 years they have the $2.5 million that they're projecting they'll need for the new water tower. Hopefully they accounted for inflation as they went along. Pretty cool, huh? Yeah. Okay. One more topic, and then we'll stop this video. You probably already noticed that due to the compound interest, the actual rate is a little bit different than what it's advertised. And that's called its yield. So there's a difference between the annual percentage rate, the APR, and the annual percentage yield. The yield is what you actually get. Okay? And the way to figure that out is to use this compound interest formula and just use a principal of $1. And that'll give you the APR, or I'm sorry, the APY. Another name for that APY is effective rate. It's like if you just compounded once at the end of the year, what percentage would give you the same as if you compounded more than once? So let's say we want to determine the effective yield. So the effective yield is also the APY, annual percentage yield, whereas the APR is the annual percentage rate. So they'll advertise both of them because usually this is higher. If you compound more than once, this is higher. So at 3.5% compounded semi-annually. So if the rate is 3.5% and we're compounding semi-annually, we want to know the effective yield. So what we do is we take A equals, we just put 1 in for P. 1 plus 0.03 divided by 2, caret 2 times 1, because it's just for 1 year. So I'll put 1 there. 1 year. What's the future value after 1 year? Because it's annual. And when I do this, I get 1.03530625. And I'm just going to truncate it there. And so this is the accumulated value. On my $1 that I started with, this is what I end up with. Well, the $1 is the principal. And so you remember the interest is equal to the A minus P. So 1.0353 minus 1, the $1 equals 0.0353. That is the annual percentage yield, the effective rate. So APY is equal to 3.53%. See, it's slightly higher than the APR. So this is the APR, and this is the APY. Hi, neighbor.
Hi.
So, you have enough ammo to do half the quiz. This is going on 25 minutes, so I'm going to go ahead and upload this one. So I'm going to call this 4A. I'll be back to finish with 4B. We're going to do installment loans. Dr. K, out.